Okay, Panthers, by now I hope you've had a chance to head the page 64, which is where this goes in the ISN this afternoon. We're going to talk about inverses for a little while. The inverse of a relation is something you can find algebraically. It's the function or the relation that undoes a function that you know. We say that the graphs of inverse functions are reflections across the line y equals x. Two relations are inverse functions if and only if whenever one relation contains the element a, b, or in other words, the ordered pair. If a is the x value and b is the y value, then the other relation contains b comma a. Trade them places. A real-world example of inverse relations or inverse functions might be the thought of tying your shoe. Tying your shoe takes an untied shoelace and creates a tied shoelace. The inverse of that operation is untying your shoes, taking a tied shoelace and creating an untied shoelace. Okay. We'll talk more about this on the white page that we'll put on 65, but two functions are inverse functions if and only if, I neglected to call them f and g, if both f of g of x, notice that's composition of functions like we discussed on Monday, and g of f of x, if they are both equal to x, you might want to change the wording there. They refer to the identity function, but the identity function is y equals x. There's an example on the outside of this yellow page. Essentially what you're going to do, and I'll let you read more carefully through this on your own time, you'll replace f of x with y to find the inverse function. So everywhere you see f of x, replace it with y. Then you will trade the x and y places. Everywhere you had written a y, make it an x. Everywhere you had an x, make it a y. And then you need to solve this new equation for y. So you can use algebraic steps to get y by itself. It's not emphasized in this example, but you need to understand this notation here, Panthers. I'll zoom in a little bit. This notation we read here, we read this as f inverse of x. This -1 is not an exponent. It's just a way of saying the inverse operation on f. So this is read as f inverse of x. You'd read this whole sentence. The inverse of f of x is f inverse of x equals 5/2 x plus 1/2. Let's take a look on the inside. Okay, Panthers, here are kind of those three key steps for finding the inverse of a relation. They don't necessarily apply to the first couple examples. I think they're a little bit simpler to accomplish. The key one to remember for any example where I ask you to find an inverse is to trade x and y places. Panthers, let's work on a couple of examples together. Number 1 says find the inverse. Okay, and this time what we've given you is we've given you a relation, just a set of ordered pairs. Well, these are all x comma y ordered pairs. And what you need to remember is that the inverse of a relation is just the relation that undoes that function. So, if 4 -3 is in the function, let's start writing its inverse. We'll write the inverse like a set as well. If 4 -3 is in the function, or in the relation, then -3, 4 ought to be in the inverse. It should have the same x and y coordinates, but they should be reversed. Here's another one. If 3 -1 is in the relation, how about putting -1 comma 3 in the inverse? You know what else we should put? The relation has 2 comma 9, so let's put 9 comma 2. And here's one more. If we had -5 -1, well, our inverse needs to have -1 -5. And there it is. You're done. This set of ordered pairs is the inverse of this set of ordered pairs, because each of these ordered pairs uses the same x's and y's but trades them places. Panthers, we're going to pause the video for just a second, and we're going to ask you to try number 2. So we'll pause the video for just 1 minute. We'll keep the time for you, and then when that minute is up, we'll ask you to check in. All right, Panthers, let's do the inverse. the first ordered pair I see is negative 2, 8, and that means that 8 comma negative 2 should be in the inverse of this relation. You know, I see positive 2, 8. Sometimes students will confuse the idea that, you know, if I've already used 8 as an x, I can't use it again. It's fine. The bottom line is just simply that the inverse here is not going to be a function because now I have one x that has two different y's. Okay. Now I have negative 3, negative 1, so the ordered pair I need is negative 1, negative 3. I see 5, 0, so I need the ordered pair 0, 5. And lastly, how about to take care of the 6, negative 2, how about negative 2, comma 6? And there's the inverse of this relation. That's a totally fair question. That could be on today's mastery assessment. Let's practice finding some inverse functions. Take a look at 3. Find the inverse. We want the inverse of f of x equals 2x minus 5. Okay. First step I need to do is, I guess even before my step 1, is I need to replace f of x with y. F of x refers to the output of the function. So instead of writing f of x equals 2x minus 5, I want y equals 2x minus 5. Now I need to trade them places. Everywhere I see an x, I need to replace it with a y. Everywhere I see a y, I need to replace it with an x. So I've got x equals 2y minus 5. And what I need to do now is I need to solve this equation for y. So I'll choose to add 5 to both sides. X plus 5 equals 2y. And then to solve for y, I need to divide both sides by 2, or maybe even easier is to multiply both sides by a half. Half of x plus 5 would equal half of 2y, which is y. And when I've got y by itself, now I need to write my final answer. Remember, instead of y, we want to write the inverse of function f. So we're going to write f, and we're going to use that same notation. F inverse of x equals 1/2 of x plus 5. And that's one answer that I would accept. That would get you full credit. If you want to distribute that 1/2 through because you're very used to doing such a thing, that's okay as well. I would also take 1/2 x plus 5/2. There's no need to give both, but either one of those is sufficient. Okay. I think what we should do now is we should, again, give you a couple minutes to work on this. We will pause the video now for about 2 minutes, and we'll keep the time, and we'll ask you to try to find g inverse for this function g. Okay, here we go. I'm going to replace g of x with y. So I've got y equals x minus 3 all over 5. And now before I do any kind of other solving thing, I need to trade x and y places. So everywhere I see a y, I'm going to put x. Everywhere I see x, I'm going to put y. And now what I need to do is I need to solve this new equation for y. I can multiply both sides by 5. And on the right side, the 5's will cancel. And I have 5x equals y minus 3. And now if I add 3 to both sides, I'll get 5x plus 3 equals y. Oh yeah, that last step, right? Don't leave it as y. Write g inverse of x equals 5x plus 3. There it is. We've got it. Okay, let's try one more. Number 5, h of x equals 3x squared. Well, we'll replace h of x with y. Remember that function notation implies that the expression we use for the function is the output, the y value. We'll trade x and y places, so now x equals 3y squared. And here I need to solve for y. So I can multiply both sides by 1/3 or divide both sides by 3. And let's see. Oh, there's that square root property of equations. If I've got y squared equals a thing, and I need to get y, I'll take the square root of both sides. Now I'll get y here because the square root of y squared is y. There's not really a whole lot you could do to simplify this. Oh, I know the square root of 1 is 1, but there's really no sense to not keep that radical the way it is. One thing that is important to remember is that when you use that square root property in solving an equation, you need plus or minus. Don't let that plus or minus monster in that closet over by where Jalen is sitting get you. So a really reasonable answer would be to not write y, but instead h inverse of x equals plus or minus the square root of 1/3 x. Full entire credit. All right, Panthers, this is ready to go. Don't glue yet. We have one more thing we want to look at together, and that's on page 65. So this video is about to end. Take a minute to get things organized and gathered, and I'll see you on the left-hand page.